Hello, can you hear me?
Yes, yes.
Okay, good. We'll wait for a few minutes.
Hello?
Hello, yes.
Oh, so Chongjin, are you talking? Maybe my audio is not good.
Yeah,
Is
I can hear you. I can hear you.
Oh, okay, no problem. Okay, that's good.
We wait for 1 or 2 minutes. It's summertime, people probably have on vacation. I think we should start at 5 after 8. I think we'll have few probably busy schedule today. Jimmy and Wei Han, you both have wanted to present something, right? And Jimmy, you want to start first, or?
Oh, sure. So I have Chongjin, I have two things. One is I kind of summarize the 3 architecture design options, right? So you want to talk
Yes.
this first, or?
Yeah.
Okay. Okay. So I will share my screen. Let me see how to work this desktop. So you guys can see my screen, or?
Yeah, I can see it.
Okay, that's good. So I kind of took a liberty of capture the 3 architecture design options so far we discussed, right? So I updated this high level document. So this no change on the first part, but so I added this section. Okay, try to capture what we have talked. Certainly, this is only my personal understanding. So anyone, if you see something incorrect or you wanna add, and feel free to do that. Okay, and so let's start for the with the first option. First option, I named the new OTN container. This is our current implementation contributed by Ali and the SONiC team, right? So in this option, so we basically modify the, okay, now another thing, oh, sorry. So So in this discussion section, I simplified it. We focused on only 3 containers, right? So there's other containers. I think the core of the optical service as well as the switching service are these 3 containers. The other will be like a generic hardware management and also northbound interface, right? We can certainly talk about that later, but this I think is the core of our system. So that's why I started off from these 3. Otherwise, there will be too many, right? So we can. So I think that the really focus is on these 3. So with the current code, we basically modified SWSS and removed the switching part, then added the optical part, right? So this is my understanding. Then on the right side, the SYNC-D is basically the line radius. So SONiC radius is original from SONiC psi radius ripple. Then we modified and removed the stuff, and SYNC-D we also changed. The psi radius has 3 major components. One is the lib, one is SYNC-D, and also the psi itself, right? Three things. So we modified accordingly and make it work for the optical transport device. So that is this approach based on my understanding, right?
Yeah. One minute,
mm,
Jimmy.
mm,
I think there's something wrong in this, in the
okay.
sense that if you're putting OTI on the left side, right, which is talking to the Redis container, that's not OTI. That's basically the PubSub interface towards the Redis. That won't be an
Yeah.
OTI. Your OTI is on the right side. It will be talking only using OTI to the line cards. And the OTI on the left, there's no OTI on the left side. It's basically a Redis PubSub from any container.
I don't know if the Ali team can correct me if this is wrong. So my understanding is Ultra Agent actually implement all the OTI API, right? Which is right to the database. Is that correct? So the vendor OTI.
I think Jimmy is correct, or both are correct, because they are slightly different between the left one and the right one. So right one is the OTI is the definition to the hardware, to the ASIC or to the OTN. On the left side, I think the hide file is the same as the OTI, but the implementation is
different.
Is operating with the right. Yeah, that's my understanding.
Yeah. So the left side is actually part of the framework, right? So vendor does not have to touch, right? Only vendor OTI. Then in there on the right side, the vendor need to implement OTI API, right? So that is my understanding. Okay. Okay.
So
then
on the left side, you're saying nothing needs to be done, right? You're saying?
No, it's actually implemented, but the implementation is right to the database.
Right, right into the database. Correct. Yeah. So basically, optical information right into the database, right?
Yeah.
Which needs to be consumed by the ASIC DB or the optical database on the right side by the SYNC-D. That's what you're saying here, right? Writing it to the
ASIC DB and the flex counter. Yes.
Right. So is that you're using a OTI there? I don't know. You can't call it a OTI, right? OTI is mostly on the right side, basically getting the information and trying to program it towards the line cards, right?
Yeah, you probably can explain more because this is.
Yeah, so we define the OTI APIs and in a hide file, and on the left side, actually it's a line Redis library or OTI Redis library. So in this library, it implements the OTI hide files, and but the difference is this implementation, they just operating the ASIC database and flex counter database. They didn't touch the hardware. Yeah.
So Harish, basically the API, they are the same, right? So left and the right, they are different implementation. Left side is the implementation is just right to the database, Redis.
Correct.
On the right
correct.
side, the vendor is same API, but they write to the hardware. Yeah. So it's like a two OTI here. But they are the same API. Yeah, it's pretty tricky. I mean, but that's how style works. Okay. All right.
I think the principle is that the org agent they don't care about the hardware OTI interface. They care about the Redis database. So they operating with the OTI hard file, they can operate the hardware, but actually they don't care about the detail of how they cooperate with each other. They just write to the database. Okay, then the framework will help them to configure the data to the hardware. So I think that's the
correct. But today, if you see, the infrastructure is already in place for you from the applications to basically write it to the database. That whole infrastructure is built in, and that's common across all the Docker containers. They all subscribe to the using PubSub to the Redis database, and once you consume the information, if you're subscribed, you basically process that information, and then you basically write it back to the database. That's how they do it today, right? So what you're saying here is you're basically accessing the database using for subscribing to some data, and writing it back to the database is what you're calling it as an optical database. Sorry, writing it back, the optical information back to the database is calling, you're using an API, which is basically calling as OTI as well. Similar to what is happening on the right side is what you're saying.
Yes.
That's my understanding of what you're saying. I think, okay, anyway, that's fine. Yeah. Okay.
Yeah. So from, go ahead.
Sorry, the current OTI interface as defined is nothing but a translation of the OpenConfig API anyways, right? So I mean, there's really not much difference there between what's, in the northbound API, right? And I assume that the database schema is also going to reflect that. So in reality, right, I mean, it's almost like a translation layer, right? You're just taking the OpenConfig and just mapping it straight to the database, and then that same API is being used to access the hardware, right? There's not a lot of transformation in that API from the northbound to the LI, right, or OTI as it's currently proposed, right? It's very similar. The northbound API and the southbound API are similar, if not almost identical. Right?
Yeah, in our case, that's true. But right now, switching is more complicated. But
exactly.
They have a protocol.
And I think that's the reason why I think, Harish, that the left and right both are OTI, because in the end, it's just really just maps to the OpenConfig APIs in the end anyway.
Exactly. Right. Exactly. I understand. Yeah. So if you okay, so that's fine. Yeah.
But I think to avoid confusion, because in the overall architectural view, right, we had always defined OTI as the interface that vendors need to implement.
That's correct.
Right. So it might be worthwhile. It might be worthwhile in this picture to call it something else just to avoid confusion for novice readers, right, that don't understand what's going on, right? So it might be worthwhile to say this is not the same OTI. I think you called it here vendor OTI versus
vendor
OTI.
Yeah.
So it might be worthwhile to Jimmy in here to define what vendor OTI is and what OTI is, right? Because the novice reader may not see that distinction, right, when they see that, right? So
this sounds to me is exactly like a southbound interface versus a northbound interface, right? So if we can draw this figure as a OTI in the middle and northbound to the database, southbound to vendor hardware, maybe more clear. This layer, OTI in the middle, right? So you should do some level of translation, but since we are using the same data model for and for writing to the database, so this translation doesn't need to happen. So I think that if that's clear, then APIs can be exactly the same and don't need any translation. But then the concept of their functionality is still clear, right? So we have a source-bound interface, we have a north-bound interface. They happen to be the same, but
Right.
then the structure can be clear, I think. Yeah.
Yep.
Yeah,
whether that holds going forward, we have to see, right? As we work on this API, it remains to be seen, in my view, right? Whether the left-hand side OTI and the vendor OTI will exactly match up or not. Or that I think we'll get further into as we discuss the API, the vendor OTI API further, right? They may end up being some divergence there based on vendor-specific enhancements and things like that, right? That happen.
Correct.
So.
Yeah, I think it might be different. In my opinion, there might be two different things is what I'm thinking. So the northbound will be, like as you said, the open configurator, whatever comes in, you basically update the database based on that. And the southbound will be more like the SI implementation is what I'm thinking. It's going to be like that, more vendor specific, and it won't be vendor specific. Vendor specific libraries will be there to basically consume from the API and then call their internal whatever APIs, right, to basically program the hardware. So that's how it's going to be, is what my visualization is.
Yeah, and that's correct, right? I mean, but as it stands right now, both that left-hand and right-side API are pretty much the same, right? Because it's literally just taking the open config northbound API and just passing it through all the way until it hits the vendor OTI, and that's where the magic happens, right? Of converting it to the vendor-specific calls to go to the line card, right? Yeah, at a very high level, it looks like that's how it is. The API is currently defined.
Yeah, I agree that. But I'm saying if you make a vendor OTI, which means it becomes Infinera OTI separately, Microsoft OTI separately.
No,
I think it doesn't make. It's OTI is that's a common layer. That's where you basically don't care about what is underlying there, right? So it is that is where it is it's an abstraction layer. It cannot be vendor's OTI, right?
Well, it's a vendor OTI implementation, to be very specific, right? So there's
exactly.
an API.
So I'm sorry. Yeah,
and this is the implementation of that API, right? That's what I think Jimmy means, right? So,
No. I understand.
So I'm sorry. The confusion is this square. Their implementation, right? OTI interface. They should be another like line on the top. So that is my mistake. So yeah, sorry.
No, it's okay.
No worries. I'm glad you put this together. I'm glad you put this together, Jimmy.
We are just converging only. Don't worry. There's no mistake, nothing.
I will modify this to be more clear. So both sides, the API the same, but the implementation is one is called the OTI implementation, belong to SWOOLSS. Okay, the other they are vendor implementation, belong to SYNCD. So, but the API they are the same. Yeah, that's the current implementation. Okay, all right, let's go back. Okay, so quickly.
If we can maybe what I'm picturing, right? So, but Jimmy, we can discuss offline and try to refine this chart. So if you put an OTI just in the middle and then there's northbound interface, there's a southbound interface, you don't have to call it a vendor OTI versus OTI, right? So in the southbound, under the southbound interface, there can be vendor implementations, and northbound is just to all the database, right? So then it's just one layer of OTI. Yeah.
Okay. I will modify this to be more clear. So okay, now quickly correct me, Wei Tan and Chongjin, because this is your implementation. So I just say like pros cons from my own point of view, right? So definitely this is a working system. So nobody can argue with that. This is the one of the first SONiC-based optical network OS. Itself has a very high significance, right? So no matter what, so that is this. And second pros I can see is the business logic of the packaging switch are removed, which is actually good, because make the system, simplify the system, because all these things, if we working on pure optical device, then these codes are really not needed. So by removing them, make it simple. However, the cons is that we really create a parallel code base of the SONiC infrastructure, right? So not like in these two containers, for example, right? And the syncd and even SI itself, they are not only business logic, there's a lot of infrastructure in there, code generation, script, all these building system, all those. So basically make a copy of these, then we effectively diverged from the SONiC infrastructure, right? So while SONiC evolving, then we needed to sync like continuously. So that is sort of, in my mind, is a con. So now it can also not support the optical packet device, right? In this model. So we are pure optical only, which is fine for the initial phase. But in the future, like there's many packet optical devices is coming out. Like Voyager is actually available a long time ago, a few years ago, and recently Cassini, same thing. So they combine the transponder and the packet switch together, right? So we can see that for now there's no open source software for this packet optical device. Only there's one or two like software company. They have the OS to run that as a white box.
Yeah. So Jimmy, before we jump to the next one, I want to
okay.
comment something on the second one. We remove or we modify some packet switching business in both OLSS and syncd. So in syncd side, I think we simplify the process of the syncd. In syncd, in switch syncd, it compares different views, the initial view or applied view. I think this logic is not required in our OTN device, and also we add the PM, the performance monitoring, the 50 minutes, 24 hours, and also the alarms and on the left side, I think totally we remove all these business from the switch, but we just keep this simplified for the OTN. I think that one is much clearer than the original one. But the OSS reuse the SWSS common, which is I think is the infrastructure for both the SWSS and OSS. So that's the modification of the original SONiC.
Yeah. So wait, are you talking about this or
yeah?
So
yeah, the last
yeah, so
one I mentioned that. Yeah.
Yeah. So you go ahead. So to explain the like your plan or your whatever the future change based on the current implementation, right? So
yeah. So the idea is that I think the left side, I think because there is already a SWSS common, so then the SWSS or OLSS, so different team can focus on the different business logic in different containers. So this logic is isolated into different Dockers. So right now the problem is the right side, as Jimmy mentioned, because we reuse or we copied so many syncd or the SI infrastructures. So right now the implementation is the day one implementation. As you can see, the syncd and the OT syncd, they share some common infrastructures, and they copy the code, and we rename the site to OTI, something like this. But actually, the infrastructure is almost the same. So we hope that maybe on day two, we can create some common library for both the OTN and the switch. I name this syncd common or site common. So these are the infrastructure, the script, the APIs, the infrastructure APIs for both different Dockers. because we found that when we developing the OTN device, most of the time we didn't touch the infrastructure code because actually the developers are working on the application layers. So we hope that one day that we can have a common library, then different team can isolate it in the business logic, but they share the same library. That's the idea.
Yeah, I think this is a good plan, right? So in my mind, the maintainability and the continuous sync with upstream SONiC, that is the most important. If we can reduce that effort, right? So then we are effectively attached to the larger SONiC community. So we just for the same infrastructure. That will be the goal in my mind. Yeah. So if we can achieve, like I say, in the picture in the day 2, then that would be perfect. So there's no duplicate code, right? So no duplicate code, then I mean the infrastructure moving forward and we moving forward too. No effort, right? Once you create the duplicate code, then it will be a bigger burden of sync up. And the SONiC is like evolving actually pretty fast. For example, I look at the Psi, right? Psi, I assume it's pretty stable, but only in this last 6 months, they have 70 check-ins already. So, I mean, then you want to catch up, then you need to know, oh, this check-in is important, that check-in is not. So that will be a bigger effort. So if
in the site, this modification, are they infrastructure change or the business because they want to add the new features? Maybe they introduce new.
Yeah, mostly I look at mostly they are the new features for switching, which we really don't care, right? So we don't need. However, there's a significant number. They are optimization, like a serialization, for example, you know that, right? Serialize, and also the bug fixes. So without going through all the list, we don't know what we miss if we stay with the older code. So that is the problem. Yeah.
That's correct. Basically, there are a lot of new features at the same time, enhancements to the existing APIs as well, extensions, and at the same time, as you say, performance also, right? They look at all these things. They keep updating these constantly, right? Because even in the last OCP when I attended, there were a lot of changes with respect to the Psi as well. They were discussing at that time.
Seems every day like there's a check-in.
Yeah, they will because it's a big so it's a similar community like SONiC, right? It's called the Open Compute Project, and there are multiple vendors which has been headed by Broadcom and other Cisco's and Junipers, right? So they do keep on updating and adding features and things like that. So it'll be an evolvement always. It'll be keeping on changing for sure. And for each releases, there'll be new libraries of for the Broadcom SDK and things like that as well for when they start building it for any library, right? So any vendor. So
yeah. Okay. So let's move on to option 2. Sorry.
I just want a quick tip here for deduplicating the code. I recently just tried ChatGPT. You just paste a bunch of code with duplicated code, right? So to it and ask it to create a libraries or create a functions for you to simplify the code. It did it pretty well. You can actually try. Deduplicating code. ChatGPT do it pretty well. Yeah.
Yeah.
Okay. Maybe we can try this.
Yeah, this is exactly what we want to do from day 1 to day 2, right? So it's the
you
goal.
Can, if you haven't tried it yet, just copy your code to it and of course remove any sensitive information, right? So if you think it's sensitive, but just copy your code with a lot of duplications to it, ask it to duplicate for you. Do it pretty well. Yeah.
Yeah. So definitely this is the best shorter term solution, right? So, but we looking for a long term like a value of our work, then we probably need to do something like this, right? So it's understand. So let's go to the option 2, which is proposed by Molek's team. In here, we kind of try to exactly solve the problem we have had. So this approach basically is the OTN function to existing containers, right? So we don't change a container at all. We just insert, like plug in the optical business logic into the existing containers, still SWSS, Redis, and also syncd, right? So, but of course, optical and the switch, packet switch, they are not really have any common kind of functions, right? So we introduced some kind of compile time switch. You can say switch or a script, which you say, okay, this is the OTN platform, right? So SONiC is a platform based, to be very clear. So we will create a OTN platform. It will be different from Broadcom, Marvell, all these switching. So by looking at the platform, you say, oh, I need this red part. So so that is sort of the and include all these. These are all the business logic and no infrastructure at all. Everything is as is in the SWSS, right? So we will include that. Now for the switching, existing switching packet, the platform, they will not include those. So effectively, this red will be gone, right? All these red will be gone for the existing switch packet. So there's nothing impact for the existing SONiC at all. So that is sort of the idea. Now at the runtime for optical platform, since we include both blue and the red, but during the runtime we don't initialize, like I say, SI API query. We don't do that. We do OTI API query. So effectively, all these green box, the code is there, but they will not be initialized and run, right? So otherwise, you need a syncd vendor implementation for the SI on the right side. So this is the basically approach we are talking here. So Pro is basically totally transparent to existing system, because when they compile their platform, nothing will change, exactly the same, right? So, and there's no duplicate code at all, because all the infrastructure is as is, used in SWSS, syncd, Redis, everything, and the database, everything. Now, yeah, HistoryDB, of course, for the OTN box, there's a special requirement like 15 minutes, like 1 day, 24 hours, this content bucket, right, which is not supported by SONiC currently. However, they are very useful. It's a common practice. All the telecom device require that. So we add a new this Ali already did that, right? Ali S-Link team already they completed that. So then the con is like, so how do I say?
Jimmy, I have a question here.
Go ahead. Okay.
Okay.
Go ahead.
So basically you have on code there, you combine on code, but you just at runtime, you just, for example, if you run OTN, you just disable the switch code, and it just for switching, you just disable OTN code. But all the code are there, right?
Yeah,
when you combine it, okay.
Yeah, software is still in the image, but we just don't run it. Yeah. But on the other side, for the switching platform, our code is not in there. This is already removed at a compile time. I mean, it's not really removed. We don't even plug in our OTN code into the switching platform. So when you build a Broadcom image, it will be exactly the same as today. Nothing changed. We don't change any line of us existing system at all. 0 lines.
Okay.
Yeah. Now
So
the downside will be a bigger image, a little bit bigger. I think it's not a bigger.
Yeah,
Okay.
bigger image.
So Jimmy, I doubt how we can plug in our OTN logic into these two containers, because I'm not sure if we can easily insert our logic into the code base. I'm not sure that, because we have because in OTN device, the line card can pluggable, and also we have alarm notifications, different kinds of alarm notifications, and also the alarms and the PM logic, and also because we are OTN device, maybe the initial we initial the switch and get the APIs. So I'm not sure if that we can insert our code without touching the main process of the SWSS and syncd. I'm not very sure on that. But if we want to touch, but in some case, if we want to touch this main process of the SWSS or syncd, I think it will be much difficult for us to convince the SONiC team that our code base will not impact their business logic. So that's my concern, and this
yes, agree, totally agree. That's what this the con is, right? So we need to figure out a way of doing that. I mean, we cannot guarantee like no single line change. For example, Ultra Daemon, right? Maybe we need to have some flag in there to distinguish the behavior between OTN device and the switching platform, right? So few logic will be needed. Zero logic seems impossible, right? So, but we want to keep it as simple as possible. So that is we will see how much we want to change. Now our prototyping, I can say that this is very minimal, either in Makefile flag or in the runtime code flag. So that will do. Prototyping, we did like amplifier and attenuate as an example, right? We don't have a complete system. Now, yeah, totally agree with Tan. So we need this is the that's a technical risk for this approach. Yes. But if we achieve that, the benefit will be big. That's what I'm thinking. Yeah. So it's a seamlessly.
But the image size will bloat, right?
Huh?
That's there for certain, because you're putting all the code. Also, the image size will be there, right? Because it
no. This red will be Harash will be in a separate repo.
Oh, separate repo.
Yeah, when during the compile time, we will include them into the SWSS. Yeah.
One question, Jimmy. How can you make the OT config manager? I believe that is an OT orchage and in a separate repo. Would it not be part of the SWSS repo?
No, SWSS it's a repo will have a submodule which point to our OTN module. It's a get a submodule, right? A point.
Okay.
Now,
so you're saying it is off of SWSS.
Yes. We will add a OTN submodule into SWSS repo. Just a link, nothing else. Yeah. Then at the compile time, of course, you can fetch, right? As a submodule. This has been a prototype. So.
Yeah, I probably basically build time environment. Then you have to pull in the case of optical. You're saying you'll pull in this and compile and build it is what you're saying as a part of it.
Exactly. So yeah, if we have time, I can go through one example of how to extend the psi, exactly psi, to include the OTI API, right? So OTI API is an independent REPL. So even code base is a clean separation. We are not change any existing SONiC code. No. So far, yeah. Okay. Now the third one, Harash, you wanna go through, and maybe I just don't wanna put my words in your mouth, but this is my understanding, right? So
No, go ahead.
yeah.
That's
Okay. So
fine.
in this approach proposed by Infinera team is basically we run parallel OLS container and OT syncd container, right? So instead of reuse the ASIC DB, and we will create a new optical DB equivalent to ASIC DB in the packaging switch, make it a much clean like demarcation from this two, right? So
Correct.
that is the plus. Plus is totally separate OTN, right?
Yeah.
Code base,
Yeah.
runtime, and from existing switch. So existing platform, zero change, and no impact, zero impact too, right? However, now if we go to deeper, now we will have the same issue as of option one, because when you create the OSS container, right? How do you create that? So you have to either write by yourself, right? However, SWS container and the syncd container, they have perfect architecture, the implementation and everything. Now, do you want to use them? Right. So if you use them, then how do you use them? Because they are already packed together. So that will be the challenge. Yeah. So that's the high level. You can add whatever you.
Yeah. I mean, I think so it's basically easier for maintainability, going back to merging with SONiC repos back. If you don't have issues, it's all kind of well defined and cleanly modularized, so that easy for any upgrade or things like that as well, right? We don't have to have any issues. And so the only thing is we definitely need to see how do we basically address the situations. If we just take an example, right, for port down event because of channel going down or something in the optical, that will basically normally in a regular switch scenario. I'm just giving it as a small example. In a regular switch scenario, what happens is if a port goes down, you get an intimation to SyncD, and basically SyncD will saying that basically update the Redis database saying that the port is down, and then the ARC agent on the left side basically will know that there's a port down event which has happened, and it'll automatically happen. But in our case now, if it's an optical, based on the channel or whatever, whether it is a OSC channel or whether it is the data, right? Whichever, how we basically inform whether the port is down or something, right? Then it would probably come to the OT SyncD. So we might have to figure out a way to inform. We can go to the Redis database and then get it to the SyncD as well. But those kind of little things are still there to be sorted out in one of the scenarios which I thought about. Other than that, it is more independent entities of optical with respect to switching, and it makes life more easier going forward as well. And the one other point which you brought, Jimmy, making both the packet and the optical in one box will be even more helpful in this case, right? We are basically thinking futuristic as well, right?
So there's I mean certain technical risk too. For example, like there's no two syncd, no two SWS is
Why do you
right?
think? No, you should not think on two SWSs. See, it's just a name which is being. If you think about it, SWSS container, it's doing its job, right? It is subscribing to some events from the Redis container to do some processing and update back to the back to the Redis container, right? It is just doing some job. So if you think about OTI, we're using, the OLSS container. It's another container. That's about it. You have to think. So when I started earlier in SONiC, right, we didn't have any telemetry container or anything like that. Now we have telemetry container. So as it evolves, we basically add new containers. It's not going to happen. It's not like you're copying the same thing. It's not the same thing. These are two different things. On the right side, similarly, SYNC D is basically catering to the needs of switches. And we are using OT SYNC D, optical sync, or we can call it however we want, to basically cater to the need of optical, right? That's how I think of it. It's not that you're copying the same thing or something. It's not like that.
Yeah, but there's a lot of effort to rewrite this whole thing, right? So that is, and you almost rewrite the same thing as SWSS and the SYNC D, right? So, because these two.
Well, why do you say it is rewriting the whole thing? What we have done today, let's assume today what we have done, right? Ali has done a pretty good job of bringing it up on SONiC, right? We just have to see what we can basically make the optical separately. That's about it. It's just nothing. You're not going to rewrite anything now, right? You have already taken the SWSS content. Ali has done a pretty good job, right, of making it to work on SONiC. So it's already there. It's just that we need to make sure that we don't do the copying stuff or something like that and then remove stuff. Instead, just take whatever is optical related and make it separate entity. We should be good in that.
Okay. So let me ask you a question, Harash. So this proposal, can I say that is same as option 1, except that you want a packet switch to container running as well?
It is correct. Exactly. That's what if you see in my presentation last week also I said, I looked at Alibaba's thing and it is basically using the same. But I think what I think in the initial presentation, maybe Alibaba, I think it is what is Wei Chang, he can probably comment on what I'm saying. They had the OLSS container on the left, basically getting it from the SWSS container, removing the SWSS container. But they had the same SYNC D running on the right side towards the hardware using the LI. And they didn't have any OT SYNC D, if I'm not wrong. They had just one SYNC D container doing it. So what I think now I saw a different picture where they had both the SYNC D and the OT SYNC D. I think what they were doing is they're taking the SYNC D and making it as OT SYNC D is what I'm thinking, right, in the initial design of Alibaba. So they can probably address my comment. I mean, address what I'm saying is correct or wrong. But I took that. I mean, I was thinking in a different angle, and then I just thought it is better to make it like this with respect to the infrastructure and the way SONiC is designed and the way we can help optical coming into this at the same time going back to SONiC and merging, and we don't have any issues. And otherwise, right? You think about the testing effort, right? If you basically make changes to the existing SYNC D and the existing code, right? The amount of testing we need to make sure that we didn't break any switching is also there. Did you hear Jimmy?
Yes.
Yeah, so that is also there, right?
I'm with you.
With this approach, you probably that is very, very less, right? You're not basically touching that.
No. Okay, so you need to go to implementation details.
No, I know.
No. The challenge is in the implementation, right? So let me explain a little bit. So SWSS container Flex Counter DB, ASIC DB, and the SYNC D. Currently, they are hardwired with the mechanism. Okay, so there's really no ASIC DB schema you process. Everything is like a code generated. I mean, the LA team can correct me, okay? Because you guys understand more probably then. So it is not like there's a logic or thing. So let me see, there's too many of this. Why every time I click this? Okay, here, sorry. So you needed to equivalent build the same thing. Instead of ASIC DB, you want to use optical DB, right? But that's not a trivial thing, unless you copy the SWSS and the SYNC D code. That is what I try to say.
No.
Yeah.
Why do you need to copy the SWSS code? I don't understand.
Wait, no, wait, and you probably can. I don't know. Yeah,
I'm
you
not
need
clear
a
on that.
copy. Mm.
Yeah. I want to fix that. The OS didn't copy the SWSS source code because there is already a SWSS common library there. So actually, on the left side of the OSS, I think is a pure OTN logic application. So right now, so it only contains the OTN.
No, not exactly. We can. You look at this picture, right? Yours, SWS OSS. They have lots of duplicate code. That itself is the problem.
Yeah, that's what I also got in the beginning.
Yeah.
You
So it's
actually
not
copied
like
the
everything
SWSS
is
and removed-
SWSS common base. You know what I'm saying?
So I think,
Yeah.
I think the key principle here is that we already have some common library. I think almost 80% of the source code is a common library. Actually, there are 20% is a framework of the SWS or OSS. Then in this framework, we add our logic, business logic in there. So the fact that I think we should focus on is we didn't touch the framework in most of our developing times because we focus on the logic. So I think here we need a trade-off because we wanna reuse the infrastructure, or we want to separate the business logic. So we need to make a trade-off here. So in my opinion, that yeah. So in my opinion, that because the infrastructure I think is the code base is smaller than the business logic. So, and the developers are working on the business logic for the most of the time. So I think, in my opinion, we should, even we copy paste some infrastructure code, but the benefits that we separate the business logic. So I think this one, I prefer to copy maybe 20% of the framework code base, but we separated the business logic. So that's
sure, understand.
Yeah.
So this is exactly the point, right? The framework of SWSS and OLS, they are the same. They are the duplicated part of our system, right? So unless we push all these framework into SWSS, like we in the day two, like same side on the right side, then we always will have a problem.
So
right?
No.
Okay.
OSS we don't push the framework into. We don't want to merge this OSS and SWSS, but because there is already a SWSS common there, so we don't need to do that. But on the right side, because there's no syncd common or side common there, so maybe we need a.
Okay, so you think basically we balance, like although there's some 20% of duplicates, but the benefit to give us will be more, right? So we will take that approach. Is that your point? Understand? Okay, it's a sort of the balance. You don't want 100% non-duplicate. It's hard sometimes, right? It's not at least for now. So you kind of admit allow some kind of duplicate code between the two, but overall it's a cleaner. So
no, but if you have duplicate code, right? If you today you're basically copying the duplicate code, what is there in SWSS, and you make it work. Tomorrow that might when you basically go back and merge, all those things might have changed. So then how are you going to handle those situations in the 30% or 40% of code which you're taking duplication?
That's a good point. So
it's a real nightmare, I'm telling you, because there will be constant changes on the SWSS. If you are taking 30% of the code and trying to basically use it on OLSS, and now when you go back to merge, and if the code has changed, you have to change your if the interface changes or whatever changes, you have to basically make all those changes again. It's a nightmare to maintain.
Yeah, it's a common. SWSS common will change it too, right? So that is another thing we need to think about.
So that is what I'm just thinking.
Go ahead, the SWS common is already there, and we reuse this library in OSS right now. So we don't. So that is already there. So in OSS we just because it's a new container, right? So this Docker infrastructure we reuse the SWSS. So I think this one is fine as I mentioned, because the benefit is more. We have more benefit if we separate the business logic. So if one day we want to merge, I don't think we need to merge this infrastructure go together, because because this infrastructure didn't change fast, but the business logic changed faster than that. So
SWSS common is very stable. You mean API wise, right? So you don't. It's not a big issue. Yeah, we don't change for sure. So it should be okay. I mean, we always can use the newest SWSS common, unless they do something very strange. Then we need to update. Right. Okay.
Correct.
So I think we spent all the time on this. Then I actually have one more topic, but we will leave it for the next time. And meanwhile, I want to ask you guys, like, how do we move forward on the OTI API, right? So we had some initial discussion, but how do we really make it happen? So I have no idea.
So right now I made the API definition and the document there. I think almost finished. And in last meeting we have some feedback on the name of some the line card or the hardware info. So I think right now we need I think I will need more feedbacks maybe in 2 weeks. So if there is no feedback, then everybody agree that the definition is there. Then we can jump to these three models, these Dockers in this high-level design. Then because we renamed the OTI, because we renamed the OTI, maybe we made some modification in the attribute and APIs. Then I think then we can start. If we make we choose one solution, then we can start to implement or modify these 3 Dockers to support the new OTI definition and and test this in the virtual machine. When this thing are ready, then I think we can propose this source code and document to the SONiC master community. Yeah.
Sure. Because this is the current code base is the only one we have, right? We don't have the other code base to working on. So I think we should be okay. I mean, once we have some agreement on the OTI API change, we should reflect into the existing system, right?
Yeah.
So yeah. So I think last time we almost agreed that all this manufacturing info should not be there, right? Is that any thing on that, or you Wei-Tan, you want to talk about next time you have some solution for that, because they belong to the platform hardware generic stuff, not the OTI.
I think we can have another discussion next time. So I hope that we can make a decision to the final OTN OTI definition maybe in 2 weeks. I hope that.
So personally, I have like 3 areas we want to kind of improve on OTI. One is the manufacturing info. These are all redundant attributes, right? So remove them to the SONiC platform. Common will be much cleaner. So any like standard API you propose should start with a minimum set. You don't want to like come out a huge one. Of course, our code base can have a huge one, no problem. But spec propose, you can always have a subset to kind of publish, right? So people can add more. Now, once you give the complete one, you cannot remove, right? So the tricky part for all these APIs, you never remove, you always add, right? So initially you don't want to put too much. That's my opinion. We can separate from our existing code and also the spec. They don't have to be like consistent every day, but eventually, of course, they will be consistent. That's my thoughts on that. Yeah.
Yeah, and Wei Tang, another thing that I also had questions on reviewing that is, how do we deal with API evolution, right? How do we, when we go forward, how do we deprecate things? How do we add things, right?
Yeah.
What is the strategy behind managing the lifetime of this API definition, right? It wasn't clear from the definition there was anything around that. So maybe next meeting we can also talk about, how that should be handled, right?
Yeah.
Yeah. So this is very important that we define a proper APIs, because once you define the API and there is already some white box implement these APIs in the market, then if you want to change this API,
it will be bad.
Very
it will
difficult,
be very
right?
bad to change.
Very bad.
Very bad.
Not impossible, if
You should
not impossible.
Yeah, you should add a new API definition. So I think because we just started the definition.
So that's my thought is you start with kind of a minimum, then you expand once you get more and more feedback. So, but our implementation can have everything. That's okay, right? Because it's a complete system. We don't want to kind of operate for now. So from the OTI manufacturing, then another thing I have no idea yet, but I found we want to consider is all these alarms definition and the threshold definition. So I'm not sure whether it's proper in the OTA API. But if we don't, then how do we do that? No, I don't know.
I guess the question, and again, Jimmy, I'm assuming you're talking about the southbound API now, not the northbound.
Yeah, southbound.
Southbound OTA. I guess really the question is, what does the OLSS container actually do, right? I think getting a little bit more visibility into all the functions, because I know, I think Wei Tang, you mentioned about alarm and PM. Is it doing all of those functions, including things like soaking, alarm correlation, PM binning, right? All of threshold crossing alerts, right? Which part of the system is performing those functions, right? I think we need to kind of have a clear breakdown of the system functions and which container is responsible for it. So that, then that will, I think, help drive the API, right? Because, for example, if all of the business logic around alarms and PM is done in the OLSS container, then the southbound API doesn't need any of those things. All you need is raw counters, gauges, right? And you need the raw defects, right? And everything else is handled at an upper layer. So we need to kind of have clear definitions of where these functions are going to happen, because that is what's going to drive what that southbound API is going to look like, right?
100% agree.
Yeah, I think, Anup, as you mentioned, right, if it is going to be just raw data which is coming and the applications can basically take the information from there, right? Then and that's an easier way of implementing, right?
It's a much simpler API southbound.
Just take the information by the OT and then push it into the database and use some whoever is, probably wireless is subscribed to that. He basically picks up that and then give it to application however he wants it, right? Depending upon what.
So that's what I want to clearly define, right?
That's a simpler way.
I agree.
That's the simplest way.
So we should clearly define that. We should draw the boundaries, right? We should say exactly what is done where, because that ultimately is going to drive how complex that southbound API needs to be. I prefer the southbound API to be simple, right?
Simple, There's a pretty general feeling is too much stuff in there, so we need probably
So I think. Good.
I think the side. I think the side principle is that they want to they want to pull more logic from the ASIC to the application layer. I think we should follow the same logic from the so maybe we should pull more logic from the line card to our main control card in the SONiC. So for example, the PM or the alarms. So right now in our box or in our product right now we implement. So these alarm are created by the line card or line card. We just save this in the database. So I think this is a good question that we should, where should we put this alarm in our system, right? So right now the PM is in the, is not in OSS, right now is in SYNCD. SYNCD can visit the vendor's OTI APIs, so it's easier to generate this PM data and keep and save in the database. So maybe there was an option that we can put this alarm and the PM service logic in a separate Docker in the application layer, but we didn't do that. I think it's a good time for the community to discuss a better way, or we choose a direction. Maybe this will impact our OTI definition.
Yeah, fully agree. Fully agree, Wei Tang. I think.
Hey, gentlemen, I think we are running out.
Yeah, we're out of time.
It's very good discussion. I think Jimmy put a very good summary. If you can update it with today's discussion, I think we have more understanding of this after discussion. I think we are converging, and we probably need more time to digest it, and eventually I think we will agree on a single approach.
Okay, so I will try to do my best. I mean, to update this document, right? So still expand a little bit for each options we have talked. Yeah, yes. Then the other people, I mean, the whole team, feel free to update. So that's everybody can.
Okay.
Okay.
Okay. Good. So I think that's we'll probably stop here today.
All right.
Okay.
Sounds good.
Okay.
Okay. Thank you very much.
Okay.
Thanks, everyone.
Okay.
Thank you. Okay. Bye-bye.
Thank you. Bye.